at a depth of 200 meters, where the ocean's blue fades into absolute darkness. Light. Once the ruler of the sky is completely suffocated, radio waves, capable of crossing deserts and forests, are halted by seawater after only a few meters. Humanity relies on satellites, fiber optic cables, and powerful transmitters just to push a faint signal through the ocean. Yet within a world where pressure can crush steel, one presence moves entirely freely. It requires no energy, slows down for nothing, and cannot be absorbed. A $1 toy magnet small enough to pinch between two fingertips can achieve what billion-dollar satellites struggle to do: create a field of influence that passes through water, mud, and stone as if drifting through smoke. The real question here is not how strong is a magnet, but rather, why is the ocean one of the densest and most hostile environments on Earth, completely powerless against magnetic fields? To answer that, we must understand how water truly treats different forms of energy, and why magnetism is almost the only force that does not need permission to pass through matter. Water appears soft and invisible, yet physically it is a formidable fortress. Each H2O molecule carries a strong dipole moment. The oxygen end bears a slight negative charge, while the two hydrogen ends carry slight positive charges. This asymmetric structure causes water to form dense networks of hydrogen bonds, constantly vibrating, rotating, and colliding with any incoming energy. When light enters water, photons interact with these dipoles and rapidly lose energy. Wavelengths vanish. One by one, red disappears first, then yellow, until only blue remains, and even that surrenders at around 200 meters. Light does not die dramatically. It is slowly nibbled away within a molecular maze. Radio waves suffer an even harsher fate. As low-frequency electromagnetic waves, they encounter seawater rich in sodium and chlorine ions, effectively a giant antenna that absorbs their energy. The ions oscillate with the wave, converting electromagnetic energy into heat, suffocating radio signals almost instantly. But when a magnet is placed underwater, something strange happens. The magnetic field remains unchanged. There is no absorption, no weakening, no bending. It is as if the water, despite its density and harshness, simply does not see the magnetic field. And this is where a ghost enters the story. Imagine standing in a crowded square. Light is like people running through the crowd. They collide, slow down, and lose momentum. A magnetic field, however, is like a breeze passing through the same space. It does not need to touch anyone to exist. It simply flows through. The reason lies in the nature of magnetism. Unlike light or radio waves, it does not depend on the density of matter, but on the magnetic structure of that matter. An obstacle only becomes a barrier if it can strongly absorb or react to the field. In most cases, water molecules cannot. Water is not a physical wall to magnetism. It is more like thin air, through which wind moves effortlessly. From a physics perspective, a magnetic field does not travel in the usual sense. It simply exists. It remains present whether water is there or not. This makes magnetism a peculiar force. It is neither a traveling wave nor a flowing stream of energy. It is a distortion of space surrounding the magnet. To block it, you need materials with special magnetic structures, something water cannot provide. If water cannot stop it, then it has only one choice: step aside. When a magnetic field passes through water, H2O molecules do not remain entirely passive. They exhibit a weak response known as diamagnetism. If a magnetic field were a strong river current, diamagnetism would be like a blade of grass at the riverbank, bending slightly with the flow, then returning to its original position. At the atomic level, electrons orbiting the nuclei of water molecules are subtly affected by the passing field. Their motion shifts just enough to create a faint opposing magnetic effect, a natural defensive response shared by many non-magnetic materials. But this reaction is so weak that human senses cannot perceive it. Water merely leans away from magnetism, like an introverted person stepping slightly aside as you walk past. not resisting, not blocking, simply acknowledging your presence for a moment. Because water's magnetic response is so faint, magnetic fields lose almost no energy while passing through it. Even a tiny magnet works with nearly the same strength in air, in water, or even in oil. This leads to a more visible phenomenon. Magnetic fields can influence metal buried beneath layers of different environments without any direct contact. Perhaps the clearest modern example is the growing hobby of magnet fishing. In recent years, magnet fishing has become a global trend. Behind the viral videos, however, lies a profound lesson in physics. Magnetic fields penetrate water and mud almost perfectly. Picture a 200-kilogram safe lying beneath thick, wet sludge. When you lower a neodymium magnet into the water, it does not need to see the steel. Its magnetic field expands outward like an invisible sphere, passing through water molecules and mud, reaching the target with silent intuition. There is no resistance, no absorption, no energy loss. Only a pure interaction between two objects with magnetic order, the magnet and the steel. That is why a palm-sized object can lift something hundreds of times heavier from a riverbed, not because it pulls harder, but because water has no authority to interfere. It cannot block, weaken, or slow the attraction. In a world where most forms of energy are distorted, consumed, or resisted, magnetic fields stand apart almost untouched as they move through matter, quiet, invisible, yet unwavering and absolute.